Free fall. The falling of a body from a height towards the earth under the gravitational force of the earth with no other forces acting on it is called free fall. So that means when we throw a stone from a tower and stone just freely falls and there is no other force, that is external force that is acting on the stone, then that is called a free fall, because the stone is attracted towards the earth by the gravitational force. So we say it is a freely falling body. An example for this we can say is a bungee jumper. We also have seen in the Galileo's experiment of Leaning Tower of Pisa, when he dropped an iron ball and a wooden ball, both the balls fell at the same time side by side. That basically led to the theory and understanding on gravitation by Newton too. So what exactly happened there is that the acceleration of a freely falling body does not depend on the mass. Whether it is made with iron or wood, they both fell at the same time. So that means the acceleration, we also understood, is that the acceleration of a freely falling body does not depend on the mass. Whether the mass is lighter or heavier, the earth attracts, it accelerates and falls at the same time. So when the earth attracts a stone, we have seen in the previous discussion that earth does not move because the acceleration experienced by the earth is highly negligible compared to the acceleration experienced by the stone. So during the free fall, what we understand is heavier as well as lighter objects see the same acceleration. Since they accelerate at the same rate, they fall at the same time. And they also did an experiment. Galileo has done an experiment with a feather on one side and a metal coin on the other side. This is to understand the acceleration and mass of the object. So Galileo did this experiment. He found out that the feather falls down slowly, whereas metal coin falls fast. Why? Because in the feather case, its surface area is very large compared to the metal coin, and its surface area is large compared to the mass. Feather is a very, very lightweight. This is a lightweight and larger surface area. Whereas in the metal coin case, this is small but heavy, large weight. This is a lightweight and this is a heavy. This is large surface area and this is small. Hence, this feather falls slowly, whereas metal coin fell fast. So due to which what happens? This will have more resistance from air. This experiences more resistance from air. More air resistance from the air is higher. Higher air resistance. Whereas in the case of metal coin, low air resistance. Due to which this lowers the speed increases here. So the feather and metal coin, though they fall down to the ground, but the way they behave when both of them are compared, the air resistance, which is an external force acting on it, will make the different speeds, hence will fall at different times. Now, when the air resistance is removed, they removed the air resistance. Now remove air resistance. How do you remove air resistance? Create a vacuum. In vacuum, there will be no air resistance. Then they discovered that feather and metal coin fall at the same rate and at the same time. So this particular experiment tells us about the definition of free fall. The falling of a body from a height towards the earth under the gravitational force of the earth is called free fall. And it will also see the acceleration of a free falling object does not depend on the mass of the object, provided no other forces acting. Now the conclusion that we see from this experiment is the acceleration produced in the freely falling bodies is the same for all bodies, and it does not depend on the mass of the falling body. It does not depend on the mass of the falling body, the acceleration. It is the same for the freely falling bodies, provided there is no other forces acting on them. Now we'll see the definition of this acceleration produced on the freely falling bodies due to the gravitational force. The uniform acceleration produced in a freely falling body due to the gravitational force of the earth is called acceleration due to gravity, termed as g, and units are meter per second square, and it is a vector quantity. So in general laws of motion, we considered the rate of change in velocity as acceleration. Now, under the influence of gravitational force, the acceleration of a freely falling body has got a new terminology which is called acceleration due to gravity. So now, having understood that, let's see how when the body falls down vertically and when the body is thrown up vertically, how this acceleration due to gravity changes. So when a body falls down vertically, the acceleration due to gravity, g, is positive and the value is plus 9.8 meter per second square, which anyway we have calculated in the previous sections. And when the body is thrown up vertically, g is negative, which is minus 9.8 meter per second square. This is called basically a retardation because the acceleration is decreasing here. So let us do a calculation of g. Let us measure this 9.8 meters per second square, how we arrived at this figure. So basically we will see derivation of g. So when an object, let's say a stone, this is the ground level and we have a stone which is of a mass m and falling down. Stone is a freely falling body. Earth is of mass m, capital M, and stone is of mass small m. And the acceleration here is, we need to find out the acceleration. So in order to find out the acceleration, we also need one more parameter, and because we are taking it with respect to the earth, we know earth's radius also. So radius of earth is also known, which is, let us say radius of the earth is r. So the known parameters for this are r, radius of earth, and small m, mass of stone, and capital M, mass of earth. Now from the Universal Law of Gravitation, we know that the gravitational force F is equal to gravitational constant G into product of both the masses, that is mass of earth and mass of the stone, divided by r square. R is the radius of the earth. So from this we understand that F is proportional to the product of masses, inversely proportional to square of the distance. We also know from the Newton's second law, force is mass into acceleration. We make this as Since we need to find out acceleration, we'll put this as a is equal to f by m. This we will make it as 2. So putting 1 in 2, we get a is equal to g into product of masses by square of the radius into 1 by m. So m gets cancelled and we get g into capital M by r square. Now we know what is g. G is 6.7 into 10 to the power minus 11 Newton meter square kg minus 2. And capital M, that is mass of the earth, is 6 into 10 to the power 24 kg. And radius of the earth r is 6.4 into 10 to the power 6 meter. Now substituting these values into this equation, we get a is equal to 6.7 into 10 to the power minus 11 into 6 into 10 to the power 24 divided by 6.4 whole square into 10 to the power 6 whole square. So which will lead us to 6.7 into 6 divided by 6.4 into 6.4 to 10 to the power minus 11 plus 24, 6 to is 12, so minus 12. So this will lead us to 0.98 into 10, which is 9.8 meter per second square. So we term this A as g. So the acceleration due to gravity for a freely falling body, the acceleration is g, which is acceleration due to gravity. Using Universal Law of Gravitation and Newton's second law, we arrive at the value for acceleration due to gravity as 9.8 meters per second square. And generally for the calculation purposes, which is also taken as 10 meter per second square for computational purposes.